I just sort of finished a little video I made here on tip compensation on a lathe tool, and I got to thinking after I made this video that I could kind of do a little bit of a series on this if this was of interest to people, because it's too much information to put in one video, and I was just trying to answer a question for this few people that have asked about it on the other videos that I've made, why the tool is doing a certain thing, like why isn't it cutting where I want it to when I change the tip radius on the lathe tool. Well, first of all, you'd have to be running a compensated tool path, and if you were doing that, then the tip radius would only change the angles and the radiuses and not the diameters. Your offsets change the diameters. But I went into a little more detail in this video, but I got to thinking this might be of interest to people so they understand on running a CNC lathe, because a lathe tool acts quite a bit different than a milling tool as far as compensated tool path. And there's zones of compensation which you have to specify in the control, and you have to specify things in your CAM software a certain way so that it ends up cutting the right way, when you're actually setting it up on the lathe over here. And this is a little bit hard to explain in answers and in various comments. And so I made this little quick video, but I got to thinking it might be a good subject matter to make a series of videos on if that was of interest. Anyway, I'm just sort of making this little introduction to this one video that I'm going to post on the subject, and I've just kind of drew some sketches on a sketch pad showing what I was talking about. I could get a little more elaborate with this if there's interest in it. So let me know. Watch the video and let me know in the comments if you think that might be of interest to you. Okay, I wanted to talk about tip compensation on a lathe and using it and how it works. This is a little bit of a complicated thing to describe. I could probably make a bunch of fancy graphics, but I'm not going to do that. I'm just going to draw on the sketch pad here and see if I can explain this in a video. This kind of would take a long time to explain properly, and I'm trying to figure out or think of a way that I could explain this quickly but make it make sense. On a lathe tool, let me just draw this. Let's say this is your part. Let me draw a chamfer on here, kind of the face, and this is the center line of the part. Now, normally on a CNC lathe, you visualize the program as the x-axis coming in this direction, and the z, of course, this would be Z0 and then going negative, and this would be the X diameter, and this would be X0. So this is X0 and this is Z0 here on the part. This is normally the way you visualize it if you're programming with a CAM software as well. Even though if lathes come in many configurations, and if you're turning on this side, like, I don't know, like an Mazak M5 or something, where the turning tool is actually on the front like an engine lathe has, it's cutting over here, but you're really programming it as if this is X plus going this way and Z minus going this way. So when you touch a tool off, like let's say you manually touch a tool off, you don't have a tool probe or anything, you manually touch a tool off, you cut the face with your tool, and you say, okay, that's going to be my Z0. So let's say let me just draw this real big. This is the radius of your tool. Let's say maybe you're touching off an 80-degree diamond insert like this, and this is the tip radius of the tool. Well, you're gonna touch the face off to this and call that your 0 point of your tool and your offset, and then you're going to turn some diameter like this diameter, and you're going to measure it, and you're going to say, okay, you're going to calculate from X0 where that tool is, and you're going to set the offset there. For the purpose of this, we're not going to worry about offsets and their values, but we're just going to discuss actual turning and the way this might work. So this imaginary point is where your tool offset is. Now, on a milling machine, obviously, your imaginary center line of your tool is the center of the diameter of your tool. So that's pretty simple. You don't have to worry about that on a milling tool. You just touch off the length and you enter in the offset the diameter of the tool, or radius. It depends on what the machine uses. And when you use cutter compensation, it would be called on a milling machine, it would take into account the radius of the tool and offset the tool path accordingly and calculate it in the control. But on a lathe, it's a little bit different. You're because of the way you touch the tool off, although you could touch the tool off here and then subtract these dimensions to the center of the radius, and then use the certain kind of tip compensation in your CAM software for that, and it would move the tool path accordingly, and then you would have to do exactly the same thing on the machine itself to make that work. In fact, with a lathe, everything has to coincide together. You have to do whatever you do in your CAM software the same on your machine, or it's not going to cut in the right place. So if you touch your tool off like I described here, which is the most common way to do it, because say you're using a tool probe, it's going to probe this part of the insert and this part, and it's going to give you this imaginary point out here as the Z and the X offset for your tool. And so if you're going to use tip compensation to go around a shape, a contour in the part, it's going to have to calculate in the control, because with using tip compensation, you program the actual shape of the part, and the machine's control is going to compensate for where this goes. Now, if you don't use tip compensation in your CAM software, you're going to see, and say you were going around this profile that looked kind of like this down the part, and it had this angle on it, what you're going to see is the tool path comes down here and it looks like it's lined up, and then it's going to go in here, the actual tool path, and down the OD like it's lined up with the OD. And you're going to, if you don't know what you're looking at here, you're going to say, well, that doesn't look right. It's cutting too much off this chamfer here. But actually, if I draw that same line over here on the radius of the tool, you see you're inside your imaginary point where your offsets control your tool to. So the control knows if you have this is going to be going around the part this way, all the way around this contour is going to be a G42 right hand comp, because you're on the right hand side of the line. If you can visualize this, like if you're standing right here, and you're looking down your shape, and this is your right hand side and this is your left hand side, when you're going around the outside this way, you're on the right hand side. So you're going to use a G42 if you're going to be using tip compensation. If not, you're not going to need anything, of course. And if you were doing a boring cycle, let's say you had a chamfer on the inside here, or radius chamfer, whatever, and you're going down here, this is going to be G41 on the inside or the left-hand side of the line on this side. So the thing I want you to take away from this to begin with is, whatever you do, most people are going to program with the CAM software. They don't. If you did this manually, of course you could do that, but you're going to be using a CAM software, so whatever settings you set in your CAM software has to match whatever you do in the setup of your tool on your machine, or it's not going to be in the right place for a turning tool. Milling tool, it doesn't really matter. You're just going to be going around a shape, and it's going to offset the end mill by the radius. But on a turning tool, that's not the case. You can touch this tool off in many different ways, and you might do that depending on what you're trying to do. Now, if you were going to use most of the time on a roughing cycle, I should say, I don't use compensated toolpath or tip compensated toolpath, because on a roughing cycle, let's just say there's steps in the part, you know, going down like this, and it's going to start out here in rough, going back, and it's going to move back this way and start again and again and again, going down in depths of cut passes, and it's going to be moving back and forth. Now, compensated toolpaths generally don't like to do that, because it confuses the control, because it's not, it wants to stay on the inside of the shape. So if you have a roughing pass that goes down here and then comes out and reverses, well, it wants to bring the radius in here, but then it wants to go back on the inside of this reversal path and then come down. Now, possibly some CAM softwares can compensate the tool and take it away and then compensate it on the roughing cycle. Generally speaking, they don't work that way. Or if you're using a CAN cycle, I'll call it, for roughing, it's definitely not going to do that. So you're going to get an alarm if you try to go down this shape with tip comp on it for a roughing cycle. So I generally don't use tip compensation on roughing cycles, or maybe I don't use it at all if I'm using CAM software. But the disadvantage in a certain way is that you cannot adjust for angles or radiuses without reprocessing the code in the CAM software. So if you change the inserts radius, you're going to definitely have to go back and reprocess the code. Now, that might not be too critical depending on the radius change if you were just roughing and then using a finish cut with compensated path. Like you might be cutting a little more on your angles or a radius. If you had a radius here, you might be cutting a little more right at the crown of the radius on your finish cutting path, but it might not be that critical. And you can also control the size of these angular or radius features using tip compensation if you need to make small adjustments because of whatever tool push off, or the radius is worn or not ideal on the insert, and so you're going to be changing this. This comes into play more so when you're cutting grooves and you have to have small corner breaks on the OD of a groove or something than it does for just general turning cycles. But you definitely could use, and I do that quite a bit on grooving tools, to tell you the truth, and maybe finish cuts on turning, but not so much with roughing cycles. I use just uncompensated tool path for roughing cycles because of the movement will generally confuse a control and give it an alarm, usually. Maybe some newer controls can handle that, I'm not sure, but most of the controls I've run, it'll tend to give an alarm, or it'll go in a direction you don't want it to go to if it's using compensated tool path for roughing because of the movement going back and forth so much. So I'm trying to make a quick video here, but see, I'm 11 minutes into this video, and most of the questions I've had are on why, if I change the tip radius of my tool, does it not change my diameters? But it won't change the diameters your tool is turning. It'll just change the size of the angular or radius. If this was a radius on the OD corner of this part, it'll change that, but it won't change the diameters, which is good in a way, because a lot of times you might want to adjust that. Like, okay, let's talk about a grooving situation. So we got this groove, we got a radius here, radius here, radius here, radius here. So this diameter, although I haven't drawn it really parallel, but say this is the same diameter going all the way down here, and you've got your let me just draw this grooving tool kind of like this. It's coming in here. This is an OD groove, we'll call it. And the tool has radiuses on it, and the groove has radiuses. Let's just say this diameter you're turning is plus or minus 0.002, and you have to put a 0.005 corner break on this groove here on the OD. This could be anything that's at least larger than the tip radius of the tool, or equal or larger. Let's just say this is 30 thousandths here. That doesn't really make too much difference. It can be all the way down to the radius of the insert and larger, and it's going to go around it all right. So let's say our insert has a 8 thousandths tip radius. I'm dealing in inches here. You know, your metric guys can convert this, but it works the same whether it's inches or millimeters or whatever. So generally speaking, you can be turning this OD, and you get this OD within your tolerance. But let's say it's on the minus side of the tolerance, and then you cut your groove, and you get your groove. And generally, these grooves are like plus or minus 0.002 as well on the diameter on the bottom of the O-ring groove, but it doesn't break the corner here, because say you're on the higher side here and the lower side here, you wouldn't have any radius there at all. I mean, if you cut this groove, and a lot of times this happens and you're not breaking this corner, and most of the time they just don't want a sharp corner there. You know, they want to break it. And although if you do what I'm talking about, you might not have exactly a 5 thousandths radius, but generally speaking, if you have a tolerance on this radius as well, you'll be in tolerance. So in the real world, oftentimes you can cut a groove after you turn this OD with a different tool, and then you came in here with your grooving tool and you cut the groove, but the corner here is still sharp, or it has a burr, or it's sharp or something. You know, it doesn't look right. And you say, I want to make that look right. And one way you can do this without changing the width of your groove or the diameter is by the tip radius of the tool, if you program using tip comp on your finish pass. Now, generally speaking, you rough a groove out without using any kind of tip compensation, and you're using the front offset. You usually run 2 offsets on a grooving tool. You run one on the front and one on the back, and generally you touch it off the same way I talked about the turning tool, where you have this imaginary point out here. So you touch off, you cut a face and then an OD, and you make that the first offset and the back offset. So what I generally do is on the Mazak you can run what they call a letter offset. So you could say, if this is tool 4, you could say tool 4, and this is be A offset, and B offset would be the back, and A offset would be the front of the tool. You can do that on the Mazatrol, and it would be 2 different offsets. On other controls, like a standard Fanuc control or something like that, I might say, if this is tool 4, like I said, I might make this 4, and I might make this back offset, I don't know, 40 or something like that. Tool 4 and tool 40. And also, I'm not going to go into this right this second, because this is a more complicated issue, but you would also have a different quadrant of compensation. This would be a number 3, and this would be a number 4 direction of compensation. 4 this way and 3 this way. If you want, I can go into that too. I'm just trying to make kind of a quicker video here to explain, because I've had people ask questions. Well, why isn't my tool cutting in certain places and cutting in other places it's doing fine? And on turning tools, this is what happens. So normally on a roughing cycle, you're going to come in here with the tool and you're going to rough whatever you do, how many passes, plunges you're taking down. And also the tool path, when you see it, is only going to be on this side of the groove if you're using your front offset to do your roughing with, because obviously the tool can't cut in here because it's going to cut the back side of the groove off. And so these are, your roughing passes are going to be coming down here, probably pecking as they come down to break the shavings. And you're going to rough like that, but then there's going to be stock that you left, you could even be in steps depending on your roughing cycle, and it's going to be all the way around here like this. it's going to leave that stock when you rough it. Now you're going to take a finish pass, and if you want to finish with tip compensation, you can't just go all the way around this thing. Well, I shouldn't say that it's possible, but it's a lot more complicated. So normally you would do half of it and then half of it. So you start with the front of the tool maybe, and you come in here to the beginning of your radius, and this will be your line you apply your compensated path on, which if you look at this, on this side you're going to be a G41, and this is going to be the left hand side of the line, so you're going to put your G41 on this line coming straight into the beginning of your radius, and then you're going to walk around here, and you're going to come back around to a point here to where your tool, this corner, isn't going to gouge this radius. Then you're going to go out here with a G40, a little line, and then you're going to wrap it out here, and then you're going to come back to here, and as you move back you're going to change to this back offset, and you're going to come down and go around the contour with that back offset up to a point where you don't gouge this side of the radius with this front of the tool, and then you're going to go G40. So this is going to be a G42 on this line and G40 on both of these lines to take away tip compensation, and then you're going to move back out like that and be done with your groove. Now, like I said, if this for some reason it cuts, all this looks pretty good, except it's not really breaking your corner because your tolerances are a little bit different here and here, and you say, man, I need to break that corner with some kind of a radius. So you can adjust the radius value in your offset. If you increase this value, it's going to take more material, as if the control thinks there's a bigger radius on this tool. It's going to cut deeper into here. But this also has the effect of changing this radius here to some degree. So you got to, you kind of balance this stuff out. But it's probably not enough to throw you out of tolerance, but you just want to get this corner broken off of this OD so you don't have this sharp edge or a burr or something. And this is the way you can do it with a grooving tool. You might not have a perfect 5/1000ths radius here, but it'd probably be in tolerance, and it might actually change this radius and increase this radius a little bit, or actually decrease it in here, the inside radius, because it's going to be pushing the tool in more, thinking there's a bigger radius of the tool. So there's this trade-off, and you got to kind of work with that to get it where you want. This is what's confusing about this is exact opposite here. When you change this radius of the tool in your offset page, it's changing. You have a radius on both these offsets. It's actually taking, when you increase the radius, it's taking more material off on a lathe tool on a compensated tool path. It doesn't make any difference on the roughing cycle if you don't have any compensation on it. Just on the compensated finished tool path. So it's opposite to what an end mill does, because an end mill, you reduce the diameter, it takes more off. On the lathe tip radius, if you reduce the diameter, the tool stands off all of the angles and radiuses more. So it's opposite. Well, once you get your head around that, it's not difficult to understand, but it's just the opposite of that. Now, there is a way to run this whole contour with one tool path. If you want to start on the back side of the offset, you could come down here and come around to here, and as you're traveling down this line of your contour, you can change to the front offset and come around and come back up and around like this. But that's really not the best way to cut this, because you want to cut your finished pass coming downward with a grooving tool, but you can do that. And I have done that on certain circumstances before. Or if you're using a full radius tool maybe, or something, and the radiuses are large, you can do that, and that works pretty good. But generally speaking, you want to cut downward on both directions for your finish pass. Now, this can also leave a little bit of imperfection right in the middle of the groove here, because the offsets could be, or something could be slightly different, and you have to adjust the X offsets to match them in the middle here sometimes. So I don't know, this video is going to be kind of long if I really go into a real in-length discussion on this, as far as the quadrant directions of the turning tools and how all this interacts with each other. Let me know in the comments if this would be worth a more in-depth discussion. I just wanted to make this point with this, that when you change the tip radius of your tool, it really only changes the angles and the radius cuts, like I've explained here on a turning tool, as far as cutting more or less or leaving more material. And the diameters themselves, the straight diameters I should say, don't change because of the way the nature of the way you touch tools off and the offsets work on turning tools. I mean, this is kind of a simplified description. I'm trying to just show what this does, because I've had questions about this on people ask me, well, why isn't it changing certain shape of my part when I change the tip radius offset? Well, the tip radius offset doesn't change the actual straight diameters on a turning tool. It just changes the angles and radius amount of material it leaves or takes away. So let me know in the comments if you want a more in-depth description of this, and I can do that for you. Anyway, thanks for watching.